Mark?
Okay, Prof.
Thank you very much, David. Well, welcome to all those who are attending this session, which is the first of the junior sessions, which are aimed to train junior participants in problem solving. For various reasons, you can participate in team competitions or in the South African Mathematics Olympiad, but primarily it is to improve your knowledge of mathematics and especially to improve your skills, problem-solving skills, which means that you are going to go beyond what we call routine problems, the kind of problems that you often see in school, namely to calculate and to factorize and so on. Here we have what we also call contextual problems or problems in context. Okay, with those few words, I just want to remind you of house rules. If your cell phone, well, firstly and most importantly, ensure that the microphone in front of you has been switched off, right? So that only I will speak, and we don't want any disturbance while this is happening. You can switch it on only when I ask a question and you wish to answer, then you can put it on. But at other times, please make sure that your microphone is switched off. I want to welcome also my good friend Mark Mancelotti, as well uh, as David Ramaboga of the South African Mathematics Foundation, who will be assisting us to go through this process successfully. All right, now we are on to session one, the very first session. As you see, the headings are averages, percentages, and rates. And we are going to go straight into the first problem, which is problem number one. Now, this is problem one, which is in the problem book, which you probably have received or hopefully have received. In that problem book, you have problems for the seniors as well as the juniors. The first part is for juniors, and that affects this particular session. And in that first part, you will see 9 sessions. And each session has got problems there written down, and those are the problems that have been assigned for the entire course. But we will only do certain problems, selected problems, and we have that list which has been sent out to you as well under the heading of syllabus or syllabi. So I will do selected problems from session one, and I would expect you to work out the problems on your own, those which have not been attempted, and you can try them out and give them to your course coordinator to check to see its accuracy, or you can email it to me. All right, and I'm sure you'll be able to get my email address. Okay, so that hopefully explains what the problem book is all about. And at each session, you will be given an assignment problem, and that problem is marked in red in the in the document entitled syllabi or syllabus. You look at the junior section and you see that session one, the problem that is marked in red is number 3, and that will be the problem, the assignment that you will have for this week. We expect you to tackle that assignment and send the solutions to your coordinator, who will tell you exactly what to do. And I think a nice program, a nice file has been prepared for you to answer your question on that file and give all your details. And we are grateful and thankful to Mr. Mancelotti, Mark Mancelotti, for having organized that. Okay, so with that rather long introduction, let's get cracking with the problems at hand. Okay, so the first problem is the average of 4 consecutive odd integers is 32. What is the largest of the 4 integers? Right, so firstly, you got 3 words here: consecutive, odd, and integers. Let's see what integers mean. Integers mean the counting numbers, which are the counting numbers are 1, 2, 3, and so on. These are the counting numbers. But the integers also include the 0, which is normally put on the left-hand side, 0, -1, -2, and so on. So it's the counting numbers together with the negatives together with 0. These are the integers. Okay, now you got the word consecutive. Consecutive and odd. The odd integers obviously are 1, 3, 5, 7, and so on. And consecutive are the ones which are next to each other. You want 4 consecutive odd integers. Like for instance, this is an example of 4 consecutive odd integers. Or it could be 53, 55, 57, 59. That's an example of 4 consecutive odd integers. Or you could have -5, -3, -1, and +1. Right? So odd integers, they differ by 2. Consecutive ones differ by 2. So that is how you get -5 plus 2, it gives you -3. And this +2 gives you -1, and so on. Okay, so you are given that the average of these 4 consecutive odd integers is 32. Now there are various possibilities for these consecutive odd integers, so you don't know what they are. So let's say if we know the first one, then we know the other 3 by adding 2 at each stage. So let's give a name to the very first odd integer. The question is, which is the largest of the 4 odd integers? Like in this case, the largest is 59. And in this case here, the largest is 9. So we need to know what the largest is. Well, let's give a name to the first odd integer. So we'll say, this is how we write this thing out. Let the first odd integer, we give it a name. Right? We can call it X or whatever. I'll call it A. All right, so now once you know the first, then you know the others. We have, okay, the first is A. The next one is you add 2 to it. The next one is you add 2 to that one. And the next one is you add 2 to that one. And that gives you the 4 integers. All right. And now you are told that the average of these 4 integers is 12. Now, what do you mean by the average? The average of a set of numbers, to calculate the average, you add all the numbers and divide by the number of numbers. So here you have these 4 numbers, you add them. We know the average is 32. So you have to add all these numbers and divide that by 4. So you have A plus A plus 2 plus A plus 4 plus A plus 6. And you divide that by 4 because you got 4 numbers. And that by definition is the average. So now, lo and behold, you have an equation because you've got an equal sign here. And there's only one unknown, namely that first integer which we named. Remember, A is the first integer. So you got 4 A's and you got 2 and 4 and 6. So that gives you 12. Divided by 4. And that can be immediately seen as, you can say it's 4 into A plus 3 divided by 4. So 4 times A plus 3 divided by 4. You can cancel that with A plus 3. So now you got 32 is equal to A plus 3. So you can solve for A. And you see that A is 32 minus 3, which is 29. So the first of these four integers is 29. All right. So let's just write down those four integers. If the first of them is 29, then I'm going to clear all these drawings and say that the first a is equal to 29. So the four integers are 29, that was the smallest one, 31, 33, and 35. The question is, which is the largest of the four? So the answer is 35. Okay, now I'm going to tell you some other things about averages, which are interesting in their own right. Um, okay, I did something wrong here, whatever it was. Okay, let me just get out of this. Sorry about this. Or, okay, let me repeat that. There are two ways of looking at averages. One is by regarding the numbers as numbers on the number line, or you can all right. So in that case, we think of the numbers sitting on the number line like this. And suppose you got, well, we got four numbers at the moment, but suppose we take five numbers and we want to find the average. And here you got the consecutive numbers, so I'm going to put them next to each other. And they are at the same distance from each other. So you can think of the four numbers being spaced out equally like that. Now, what is the average? The average is the number which is right in the middle of the whole lot here. So the average will be some number in between here like that. See? And right in the middle. If I had five numbers, it's very easy to see what the average will be if I had five numbers. And because then you can see the average will be one of the numbers. In that case, you have 1, 2, 3, 4, 5. And the average will be the middle number. See? But when you're working with if you got an odd number, then there is a middle number. If you got an odd number of numbers, there is a middle number. But if you got an even number, there is no middle number, as you can see. But it will have to be the average of the middle two. Right? So it's a nice way of looking at averages. It'll be, especially in this case here where they're all evenly apart. It doesn't work when they are randomly scattered along the line. So in this case here, you got this average here is 32. You got four numbers. So the one right here is 32. And these two numbers, they are separated by 2 units, right? So this has to be 31, and this has to be 33, right? Because this is the average of these two, and the distance between them is 2. So if this is 33, the largest is 35. See? So you can see the answer very quickly if you understand the geometry of this, right? By geometry, I mean that if you regard the numbers on a number line, you have a visual picture of what averages are. Okay, now the other very extremely important thing is what is the formula for the average, right? Let's interrogate that formula. If you say A is equal to average, give symbols, N is equal to the number of numbers. And then S is the sum. Then the formula for the average is to calculate the average, you work out the sum and divide by the number, right? So this gives you a formula for the average. You have to remember, this is the average, this is the sum, that is N. But a nice way of looking at this is that means the sum is equal to N multiplied by the average. Very useful. That if you know any two of these three, then you can work out the third one. You simply substitute the number times the average is equal to the sum. Okay, so that's important. Now, the sum is equal to the number times the average. Let's get on to the next problem, because we have a few more average problems coming up. Okay. So let's look at this. I've written down this fact here. If the sum of n numbers is S, then the average is equal to this, and hence n times A is equal to S. Now, a set of 12 numbers has average 18. Right. But the smallest and the largest have average 28. So what have we got? We've got 12 numbers. Let's give names to those 12 numbers. You can call it, you don't need to give names, but you can just think of 12 numbers, various numbers. Right. The average is 18. So in other words, if S is the sum divided by 12, that's equal to 18. Right? So therefore, S is equal to, you can work it out straight away. I'm going to write it down here. S is equal to 12 times 18, which is equal to, you can work this out, it's 216. Now, they say the average of the smallest and the largest is 28. In other words, if you list all these numbers, smallest and the largest, and you have all these other numbers there, the average of just these, first, the smallest and the largest is 28. So what does this mean? It means that the smallest plus the largest right? The average is 28. So it must be 2 times 28. Because the smallest plus the largest divided by 2 is 28. So as we said earlier on, the sum is equal to the number times this. Now the question is, what is the average of the others? Now the others, there are 10 others. Of remaining 10. Right? The smallest plus the largest, these two add up to 56. Everything adds up to 216. So the sum of the remaining 10, you have to remove this sum here from 216, and that gives you the sum of the remaining 10. And to find the average of that, you simply divide that by 10. So that gives you, if you work this thing out, you get 160. 160 divided by 10, so the average of the remaining 10 is 16. Right, so the average is equal to the sum of the numbers, which is 216 minus 56. You can calculate that first, and then you divide that by 10. Okay, so that's the second problem. And problem number 2. So now we go to the third problem, and this one I marked in red because this is your assignment problem. Okay. So you've got an assignment. I'm not going to discuss this, but you have some question. Here, one comment. Another word for average is mean. Right? Mean and average mean exactly the same thing. Okay. So some people call it mean, other people call it average, but they mean the same thing. The word mean has got several meanings. What does mean mean? Does mean a bad person? Right. So if you want to just get on to the next slide here, which is problem number 4. Emilia writes down the numbers 5, x, and 9. Valentin calculates the average of each pair of these numbers and obtains 7, 10, and 12. What is the value of x? Now, these problems were given to you a few days ago with a request that you must try to work out these problems yourself. Now, I hope and trust that all of you have done that. And if you haven't, please do that in this session, in the next session, and in all the sessions to come. You must try the problems before attending a class. You don't learn mathematics by listening to the answer before you even know the question. Right? Here I'm giving answers to questions which you would have already considered. So for your own good, try the problems. Right? If you succeed, that's fine. You can check it with the answer that I give. If you don't succeed, that's also fine, because then I will tell you how to do it, and that will increase your knowledge. So you can only benefit by trying the problems before coming here. So this problem here tells you, let's understand it first, that 3 numbers. She calculates each pair, the average of each pair. Now, they come in pairs now, 5 and x. That's one pair. X and 9 is another pair. 5 and 9 is the third pair. So there are only 3 possible pairs that you have, right? So these are the pairs. And the average for each one is, we don't know which is which, but we know that the average is 5 plus x over 2, x plus 9 over 2, and 5 plus 9 over 2, which is 7. So these are the averages. Right, we don't know which is which, but actually we do, because you can see 7 is also already included here, right? So that means these 2 here are these 2. Now, which is which? Now, this is x plus 5 over 2, and this is x plus 9 over 2. So obviously x plus 5 over 2 is a smaller of these 2, and the smaller of 10 and 12 is 10. So immediately you have an equation, right? And you can solve x plus 5. Half of x plus 5 is 10. So x plus 5 will have to be 20. Or otherwise, you can say x plus 5 is 2 times 10, cross multiply. Okay, and then x is equal to 20 minus 5. Therefore, x is equal to 15. So this was the question. What is the value of x? Okay, fine. We say the answer to the problem is 15. Let's just check to see. We said that this is, when x is 15, you have 5 plus 15 over 2. That's 20 over 2. That's 10, right? Okay, that's the second average. Let's try 15 here. 15 plus 9 is 24. 24 divided by 2 is 12. Yes. So we've got x. So this is a way of checking to see whether our answer is correct. And certainly have that it is correct. Okay, so let's, now, if you have any questions, please raise them in your chat column. You've got a chat box there. You can just go into chat and write a question down. And at the end of the session, if we have time, I will try to address those questions. But if we don't have time, then the organizers will send me your name and the question, and I will correspond directly with you. But if it happens that we've answered the question at some point or the other, just delete the question. So and only the question that are unanswered, you can send that to the chat box. Okay, so this finishes question 4. You can get on to the next one, which is question 5. The average of U and V is 200. Now, you're not given these numbers. You got two numbers. The average of that is 200. The average of X, Y, and Z, another 3 unknown numbers, is 150. Determine the average of U, V, W. Oh, there's no W. All right. Actually, this is a second error. Please note that in your problem book, there is an error there. I think I had V, W, X, Y, and Z. So it's not supposed to be V, W, X, Y, and Z. It's supposed to be U, V, X, Y, and Z. I took 5 consecutive letters of the alphabet here. But in the problem, they are not consecutive. U, V, you got X, Y, and Z. Okay, so you need to work out the average of U, V, X, Y, and Z. Now let's see what the goal is. In other words, I want to add up all these things to find the average. I'm going to put that at the bottom to say that this is where we need to get to. The required average, we put REQD is equal to, you add up those 5 numbers, now you've got symbols, U plus V plus X, Y. All these are numbers, but they've got symbols in their place, and you divide by 2, but divide by 5. So that is what you mean by the average. All right, so we don't know what this is, so this is a question mark here. So now let's have a look at what we know. The average of U and V is 200. So we can say U plus V divided by 2 is 200. But let me just say the sum is equal to the number, which is 2 times 200. I can write this down straight away. Right? If you don't like that, you could have said U plus V divided by 2 is 200. Therefore, U plus V is 2 times 200, which comes to the same thing. Right? I went to that straight away because we are using the formula S is equal to N times the average. Very useful. Okay, so you've got U plus V is 400. Let me put it down here so I have enough space. Likewise, the average of X, Y, and Z, X plus Y plus Z, there are 3 numbers there. So it's 3 times the average, which is given to be 150. So it's 3 times 150, which is 450. Okay. Now, if you don't like that, you could have gone straight to the definition of what average means. And you could have said, the second statement says, the average of X, Y, and Z means X plus Y plus Z. When you add them and divide by 3, because there are 3 symbols there, that is 150. And then from here, you can say, when I divide this number by 3, I get 150. So the number must be 3 times 150. I went to that straight away. I skipped this because I'm using the formula. Sum is equal to number times the average. So it's a very useful formula. So now we need to work this thing out. We've used all the information that is given. So you can see here, I'm adding all these. I already have that. So your required average, which is this, is actually, I can substitute straight away here now. U plus V is 400. And here it's 450 because I've just worked out X plus Y plus Z. And I'm going to divide that by 5 because there are 5 symbols here. So you got, now when you work this thing out, you get 170. So that's the answer to this question. The average is 170. Okay, so you can see we can do this systematically, but the important point here is that determine the average of that. So I took down the goal. What is the question? And I put it down right at the bottom. So I know where I'm going to. It's extremely important to know what the question is so that you know whatever you do is directed towards that question and its answer that you're looking for. So I wrote down, determine the average. So I wrote down what that means. And I said, I need to calculate this. And that is how I built this thing up. And once I came to these two, then I can get to my answer. Right? So it's important to know what the goals in every problem are so that you can work towards it. So this is an example of that. Okay, so I now go on to, okay, let me just ask at this stage, are there any questions you want to ask me? If you have a question, you can unmute yourself and you can ask it so we all can hear it. But only do that if you have the question. Don't unmute otherwise. Are there any questions? I think I was muted there. Let me say that again. A square is changed into a rectangle by increasing two of its sides by p% and reducing two others by p%. The area is reduced by 1%. Calculate p. Now, we need to have let's have a picture of this because all this is very abstract at the moment. So let's just draw the square so that we can see. Okay, so you got a square and two of the sides are increased by p%. All right, so a square, all the sides of a square are the same. We don't know what the sides are. They don't tell you what the sides are. Now that's very important information, which means that it doesn't really matter what what number you put for the sides, you're always going to get the same answer because they don't tell you what the sides are. But maybe that's not a very safe supposition. So let's just give a name to the sides because we don't know what the sides are. And so let's call these sides A. All the sides are A. Right. Now, the square is changed into a rectangle by increasing two of its sides. So let's take the side here. We want to increase this by P%. Now, this is very crucial. What do you mean by saying that a number is increased by P%? Let's take an example. Suppose I take a number like 120. And I want to increase this by, let's make it 10%. So what do we do? If you want to increase 120 by 10%, you work out what 10% of 120 is. 10% of that is 10 over 100. We won't simplify for the time being. And then you work out 10% of 120, right? And that is your actual increase. Your increase is 10%, right? But the new answer is 120 plus, because the 120 has been increased by this amount, okay? So the idea is you take your original and you add it to 10% of the original. And that is your new answer. Whenever you increase a number, so if I increase a number by like A, and I increase it by P%, then from what we said here, it is the original number A, but you have to add to that P% of A, like what the way we did 10% of A. So P% is P over 100 multiplied by A, like what we got here. Right, and now that means that you got A is a common factor now, you see. You got A plus A times something. So you can take A out. A goes into the first thing one time, and A goes into the other part, P over 100 times. When you expand this, you'll have A times 1 plus A times P over 100, right? Bingo. It's exactly the same thing. So when you can take out A, and you can make the sum, which is originally a sum, into a product. Now, this is a very, very, very important thing in mathematics, where you can convert sums into products, provided you got what you call a common factor, right? And A is a factor here, A is a factor here. This is A times 1, and this is A times P over 100. So you got, and it's a factor which is common. You take it out, you get this. So when you increase something by P%, you're going to get that, right? So that's what I got here. Firstly, if a quantity A is increased by R%, its new value is A plus AR of 100. But you see, I've also got decreased here, because in this problem, you also got reducing, right? One side is increased and the other is decreased. So in the same way, I'm going to draw my rectangle now. Let me just delete all these things. I'm going to draw a rectangle. Like that. And now the dimensions of this rectangle are, from what we have just said, the dimensions are, the one side has been increased by A. We can make this A into 1 plus P over 100, which is A plus AP over 100, right? And the other one is decreased. So there you would have A minus AP of 100 because you have made it smaller. The P% of that is P over 100 times A, but it's decreased, so you have to subtract it. So when you take the common factor out, you have. All right, so now you have what happens to the dimensions or the sides of this thing. And we'll come to that. So that is the first sentence. Now the area is reduced by 1%. So in other words, when this area here, whatever it was, that area is now reduced by 1%. So it's now come to, the original area was A. Oh, by the way, A is equal to A squared. You know how to work out the area of the square. Right, so the area A squared is reduced by 1%. So from what we said here, this is equal to A squared into 1 minus, right? We have 1 plus P of 100 when you increase. When you decrease, it's 1 minus P, the P of 100, but the P is given here. It's reduced by 1%, so it's 1 over 100. So the new area is the old area decreased by 1%. So you work out 1 over 100 of that, subtract it, and A squared comes out as a common factor. Okay, and now we are ready to solve the problem because I've just recorded all the information here. Whatever information was given, I recorded it. And now look at the question, calculate P. So we need to get an equation involving P, all right? This is one of the biggest things in problem solving. When you've got an unknown, then you try to get an equation and try to solve it, right? That is how you solve for unknowns. That is why you study equations in school, because equations, you've got unknowns which can be solved. Now this thing here, you've got a rectangle here. You know how to find the area of a rectangle. The area of a rectangle is length times breadth. So I've got the breadth, I've got the length. So the area of this rectangle is, let's work out the length first, A into 1 plus P over 100. That's your length, multiplied by the breadth, which is A into 1 minus P over 100. That's your breadth, and that's equal to the area. But we know the area. The area is this. So it's A squared into 1 minus 1 over 100. Right, so there it is. You've got an equation. And happily, you see on the left-hand side, I've got 4 numbers which are being multiplied. A, this one, A, and that one. 4 numbers are being multiplied, but the two of the numbers A and A together give you A squared. So I can just put these 2 numbers in a single. If I group the A times A, then I will get A squared. So I've got now A squared into, instead of putting the multiplication sign, I just want to take the multiplication sign out, right? Because you can put them next to each other. So you got A squared times this is equal to A squared times that. The A squared cancels happily. So, or you can divide on both sides by A squared, right? And then you have 1 plus P over 100 times 1 minus P over 100 is 1 minus 1 over 100. Now, you've got an interesting object here. 1 plus P over 100 times 1 minus P over 100. I'm taking into account that there are some learners here who might not be very familiar with symbols, and you are in grade 8. So let's just talk about this. This is very important. I can eliminate this picture here. Now this is when you got 2 numbers and you add them and you subtract them, then, and you multiply those 2 numbers, you will get the square of the first minus the square of the second, always, right? I'm going to leave that to you as an exercise to see why that is so, but we can test it. For instance, I can take 9 plus 7 times 9 minus 7. On the one hand, 9 plus 7 is 16. 9 minus 7 is 2. 16 times 2 is 32. Right? But I'm telling you that this is 9 squared minus 7 squared. I'm saying a plus b times a minus b is a squared minus b squared. What is 9 squared? 9 squared minus 7 squared. 9 squared is 81. 7 squared is 49. Subtract. Lo and behold, same answer. I'm just testing this. This is not the proof, but I'm testing the truth of this. And it's true no matter what A and B are. That's a beautiful thing. So this is great power in algebra because you don't use numbers, you use symbols, and you have all these beautiful formulae. So here I've got 1 plus p over 100 times 1 minus p over 100. I got these two numbers are being added, they're subtracted. So this is 1 minus the square, 1 squared, which is 1, and you got p over 100 squared. And that is equal to 1 minus 1 over 100. So on the left-hand side, you got 1 minus, it's a squared minus b squared. So it's 1 squared, which is 1, minus that squared, right? And then on the right-hand side, you got 1 minus 1 over 100. Okay, so the ones, now you can see the 1 minus, these things cancel off. So in the end, what you have here is, sorry, I don't have much space left here. I'm going to take out all the stuff so I can write this thing here. So I got p over 100 squared is equal to 1 over 100. Why is that so? Because the ones cancel, you got 1 on both sides. And if you take 1 to the other side, 1 minus 1 is 0. But you can just cancel them off on either side of the equation and ignore the minus sign. And I'm left with it. So when you square p over 100, you're going to get 1 over 100. But 1 over 100 is 1 over 10 squared. So therefore, p over 100 is actually 1 over 10. P over 100 squared is 1 over 10 squared. So p over 100 is 1 over 10. And then, so now you can work out p. So what must you put? What is the value for p to get the answer 1 over 10? And you can see you'll have to put p equal to 10. 10 over 100 is 1 over 10. But if you don't like to do that, you can use algebra to still get the same thing. And that is, you cross multiply 10p is equal to 100 times 1. And then we've got fractions you can cross multiply. And p is equal to 10. 100 over 10. So that's the answer. So this is a rather long problem, somewhat difficult and demanding, but I hope you have followed this thing through. Okay, it's going to be, it has been recorded, and the recording will remain for a week on the wherever it is, and you can access it to go back to try. If you didn't understand some things, you can go back and replay it so that you can understand it. Okay, so that's it. I'm going to get on to the next problem. The next problem is this problem. A flag is made up of 3 strips of equal width. Okay, you've got a picture of the flag here. So you got 3 strips. Okay, there's a strip, there's another strip, and they all got equal width. Okay. Each strip is divided into equal parts. So you got this first strip is divided into equal parts, but there are 4 of them. Okay. And here, so all these 4 areas are the same. And here too, these 3 areas are the same. And here the 4 areas are the same. And then some of these strips are painted. They're painted black and white. So the colors are B and W, standing for black and white. So the question is, what fraction of the flag is painted black in color? So once again, we don't have the dimensions of the flag, but we want to know what the fraction is. Um, so you can use symbols. And you can say, suppose there's each of this, the dimensions of the small rectangle are A and B. Right? But then you have this problem here, which is a little bit, then you'll have to have another symbol, although the breadth is the same, but you'll have to have another symbol for the length. But that complicates matters. So then you have too many symbols. So putting symbols here is not going to help you too much. But what we can say is that, look, all these strips have got the same area, and you are dividing the area into 4 equal parts in one case, and in another case, you're dividing into 3 equal parts. So why not have a number which can be divided by 4 and also divided by 3 without making life too complicated, right? So which number or numbers can be divided by 4 and also divided by 3 to get nice answers? I don't want fractions. Don't tell me 7 now. 7 divided by 4, 7 divided by 3. You get all these nasty fractions. But suppose now I say, what number can be easily divided by 4 and by 3? Okay, and the answer is 12. I don't think you require too much of thought for that. So the answer is 12. So let me say that each of these strips is 12 units long. And then it becomes a little bit easier to work with, because now you know that this 12 is now divided into 4 equal parts. So let's just equalize them. Now we can say we know exactly what each part is. So this is 3, 3, 3, 3, because we are saying this whole thing is 12. Right. And here, this part is divided into 3 equal parts. So you're dividing the same 12 into 3 equal parts. So you're going to have 4, 4, 4. And at the bottom, you got the same as what you had at the top. So each part there is 12. I mean, 3. And now you got numbers. And you can, and now it'll be very easy to calculate what fraction of the flag is black in color. So the blacks are occupying those two. Let's just ring those. The blacks are occupying the first and the last. The blacks are occupying again those. So the total black, we can now calculate it. 3 plus 3 is 6 plus 4 is 10, 14, 20. And the four threes, which is 12, and 2 fours, which is 8. So 12 plus 8 is 20. And the fraction of the flag, so the area of the flag, the entire flag, we don't have to add up all these numbers here, because we said each is 12, right? So it's 12 times 3. Okay, it will be wasting a lot of time if you're adding up 12 numbers. We already know you got 12 occurring 3 times. So the fraction that we're looking for, the fraction of the flag is painted black in color. So we got the total black, we got the total flag, and the fraction of the flag is going to be this. And so you can simplify this by cancelling taking out the common factors. 20 over 36, 4 goes into 20, 4 goes into 36, and then you can cancel that off. 4 times 5, 4 times 9. So the answer is 5 over 9. Okay, so that takes care of that. And we go on to the next problem. Okay, before I go on to the next problem, I once again like to invite you to ask any questions. The chat column has got one question. I'm going to address that now. Okay, it's not a question. Thanks, Mark. Ms. Ancelotti has put on chat here. The recordings will go into the SAMF YouTube channel. So you go to browser and go to YouTube, and then the link will be found there. And Ms. Ancelotti has been kind enough to put the recording on the chat, so you can go and listen to it. And you can tell the others who have missed today's session, you can tell them to do exactly the same thing, so they can go and listen to the whole lesson, and they'll be prepared to come the next time. Regarding that, there are three important things I need to say. One is that you have to learn to be punctual. We're going to start at 5. For the last 2 sessions, we started 5 past 5, and then 3 minutes past 5. But in future, we are going to start at 5. So if you're not punctual, you're going to lose out on the first part of the lesson, of the session. Okay, that's one, punctuality. The other one is regularity. Right? You've got 9 sessions, and as far as possible, I know you have tests and all those things, and these 1.5 hours can be quite tiresome or quite demanding on your time. You might not be able to attend, but try to attend as many as possible. Be regular. Right? If you miss one session, then you're missing important pieces of the puzzle, which will be used in other sessions. Sometimes you might use information, and I'm not going to repeat. So you can, if you miss something, again, Mr. Ancelotti has been kind enough, put it on a recording. You can listen to the recording so that you are quite familiar with what has happened in the session that you have missed, so you can continue smoothly to the next one. Okay, so that's the second one. The third one is that after all these, at the end of the 9 sessions, you see you are given assignment problems for each one of them. Today's assignment problem has been marked in red, or it is number 3, I think, in your problem book. Session 1, problem 3 is ringed in red, and you go to that, solve it, and once again, go into YouTube, and Ancelotti will tell you exactly what to do and where to paste the solution, right? And once you paste the solution, it will be marked, and you will be assigned a mark. And that maximum mark out of 9 sessions, each mark will be worth 10 marks. So you'll have a maximum of 90. All those marks are added together, and you will be assigned a final mark. And that, together with our assessment of how regular you have been and so on, the mark will be the major criterion that will decide whether you will be given a free trip to Stellenbosch in December at the end of the year, all expenses paid, I think. David can correct me on that. And there you will be given a very, very strong furtherance of your mathematical knowledge to advanced problems. And from there, they will choose a team which will represent South Africa, the Pan-African Mathematics Olympiad or the International Mathematics Olympiad, both of which are very prestigious. So you have a chance to go hit the jackpot. But this is a starting point, right? So I'm giving you the rules. All you have to do is to obey the rules, and you can achieve great heights, right? You're all watching the Olympiads, so you know that these people are number 1 in the world. They also started the same way in the little clubs, and eventually they have come to the top. But they were diligent and regular and committed. Okay, now we get on to the next one. Now this problem here, you got a multiplication sum, if you notice. Or a lot of things are being multiplied, but you got a lot of, in fact, a lot is an understatement, because you're starting from 1 minus 1/3, 1 minus 1/4, and you got dot, 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 which means you continue in the same streak. The next one will 1 minus 1/6, then 1 minus 1/7, and so on and so on and so on until you come to 1 minus 1/100, God forbid. You got a lot of numbers which are being multiplied here. There's one, you can count them, 3, 4, 5, going all the way up to 100. Now, how many numbers are there in that list? Well, you might think it's 97, some of you, but it's actually not 97. The reason is that the numbers which are missing are 1 and 2. Altogether, you got 100, and you take out the missing ones, only 2 of them. So it's actually 98. Right? So it's 100 minus 3 is not the correct answer. It's actually 100 minus 2, 1 less than that. Now I'm saying this now, and I probably won't say it again. It's very important to know how to count a list of numbers, right? They're consecutive numbers. You simply, like for instance, if you want to count how many numbers there are in this list here, 213, 214, 215, all the way up to 1012, right? How many numbers are here, right? The answer is 1012 minus, not 213, but 212, which is 800. So the 800 numbers in this list. Right, so that's quite useful to know. I digressed to give you important information. I hope you remember that when the crunch comes. Okay, now let's see how to do this. Well, we can actually calculate 1 minus 1/3. So why don't we do that? This is 2/3. 1 minus 1/3 is 2/3. 1 minus a quarter, when you're taking a quarter away from 1, you're left with 3/4. So the next bracket is 3/4. Now here, similar, it's 4/5. Because if you add 1/5 to this, you get 1. See, it's another way of asking this question is, what must you add to 1/5 to get 1? Right? To interrogate what you mean by subtraction. What must you add to 1/5? That is 4/5. And now this is being multiplied by the next one, 5/6, and so on. I'm going to put dot, 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 dot. And then right at the end here, you got what must you add to 1/100? It's 99/100. And the one just before that would have been 98/99. Because you would have had 1 minus 1/99. So it's always nice to put the last one as well as the one just before that, right? So then you have a clear picture of what's going on. This is an important rule. Put the last one and the one just before that, and you can calculate it. Now, if you look at this is a product of various fractions. You might want to say this is 2 times 3 times 4 times 5, all the way up to 99, and 3 times 4 times 5 times 6, all the way up to 100. And no calculator will give you the answer to that question, because no calculator can multiply 2 times 3 times 4 times 5 all the way up to 100. It's got, I don't know, 50 digits in it or more. So this doesn't help. But the nice thing about fractions is that you can cancel. See, you got a 3 at the bottom, 3 at the top, you can cancel. You can take out common factors. Right? Very, very important. You learned this in primary school, 21 times 12 times 14, big enough, 22 over 77 times 8. The way to do this, don't multiply all these and this and divide it and use your calculator. You don't need calculators most of the time. In our course here, we don't, calculators are forbidden. 7 goes into this, 7 goes into that, right? The 11 goes into 22 2 times, 2 goes into 8 4 times, 4 goes into 12 3 times. Lo and behold, 3 times 3 is 9. That's the answer. No calculators used, and you can multiply all these things and get an answer very quickly. So this is what is happening here. These things are cancelling. Not even looking for common factors. They are already there. You just eliminate them. So that 99 also cancels. And this 98 would have been also eliminated by the previous guy. So the only survivors here are that one that hasn't been knocked out. The rest of them have been knocked out. The 6 would have been knocked out with the next one. And this denominator here, 2 over 100, and that's 1 over 50. Right? By simplifying 2 times 1, 2 times 50. Always nice to take out common factors. Okay, so that brings up to question 9. Let me go on. I think I've just got 20 minutes left. I might not be able, I might have a problem with time. So I was going to stop and ask you if you got any questions. I'm going to hold on with that. Still got four questions to go for 20 minutes. So let's just, the harder questions are coming towards the end. So let me go and do this. Well, not necessarily. I didn't choose them so that they are degrees of difficulty. Okay, Ayanda, Khert, Tina, and Precious are good friends. Precious had no money, but the others did. So Khert gave Precious 1/5 of his money. Ayanda gave Precious 1/4 of his money. So let's just write this down. So just let's we'll put G. G, what did he do? It's nice to draw a picture so you have an idea. He gave Precious 1/5 of his money. So he would have had 4/5 of his money left. Oh, I'm sorry. Let's just put 1/5 here. Right. So he gave Precious 1/5 of his money. Right. So we've recorded the first piece of information. Ayanda gave Precious, again, the same person, 1/4 of his money. And Tina gave Precious 1/3 of his money. Now, each gave Precious the same amount of money. In other words, all these are the same. See? So this number is the same as this number, it's the same as that number. So what do we have? So what did Precious have? Now Precious would have had 1/5 of G's money, which means that G's money is 5 times Precious' money. Okay, that's understandable because he gave Precious 1/5 of that, which is P, which is what he gave to P. So likewise, remember he gave this to Precious. I'm going to count how much of money did Precious have, right? So this is the amount that Precious has got, but it says here that each gave Precious the same amount of money. So these are all equal. So this is precious is money, this is precious money, this is precious money. All of them are equal to the same thing. So 1/4 of A is P. So you also got A, for the same reason, will be 4P. Right? So A would have had 4 times what the precious had. And Tina would have had 3P. Because they all give precious the same amount of money. So these are the same. So you got 3 equations here, but they are very simple equations. In each case, you can get rid of the fractions. I don't like working with fractions. So I multiplied by 5. Otherwise, just common sense says that if P is 1/5 of G's money, G has to be 5 times P's money. So now you got this situation. So what fraction of the group's money does Precious now have? Now the group's money, altogether is, originally it was G and A and T and 0. That is the total amount. The Precious didn't have anything, right? And so you got, when you add up all that, you're going to get 3P. P plus P plus P. No, I'm sorry. Yeah. It's 5P plus 4P plus 3P, which is 12P. That is the total amount of money which was in the group's hand, G plus A plus T. And this equals the group's money. So what happens to P now? P, how much of money does P have? Let's put Precious. How much money does she have? Well, each of them gave a P, so she's got 3P. That's so important. You have to understand this problem quite nicely because she received P from each one of them. So therefore, altogether, she would have had for each of the other 3, so and all of them would give the same amount. So she's got 3P. So this is what she's got. Precious has got 3P. So the fraction that we are speaking about is whatever she has got, which is 3P, over the group's money, which is 12P. And again, 3 times P over 12 times P, P's cancel, 1/4. So the answer is, what fraction of the group's money does Precious have? It's 3P divided by 12P. Okay. So the way we did this is that we did it systematically, taking each fact here and recording it, right, separately from the others. And then eventually we see, I should have done this because this is what the impression I gave you earlier on. What fraction of the group's money does Precious have? We should have said at the outset, what are we going for? What is the goal, right? And then we should have said that the goal is you needed to have, to work out what fraction, you needed to know what the group's money is totally, and you need to know what Precious money is totally. So that is the goal. And what is Precious at the end of the exercise, right? They say now I have, and then to calculate the answer, you put the Precious for groups. So that is why we have to calculate the group's money altogether, and we got it in terms of just a single symbol, and that is how we were able to get the answer. Okay, so let's get on to the next question. The next one is this problem here. So what is the value of square root of this funny looking thing squared, and the square root of this thing, which looks something like that, but it's got a minus plus sign, squared. All right, so we have to calculate the square root of something squared. The square root of 5 squared. Right? 5 squared is 25. The square root of that is 5. The square root of a square is itself. Square root of 10 squared is square root of 100, which is 10. So it looks as if square root of x squared is x. Because that's very nice, because then we can work out the square root of this squared. You can write down square root of this squared is just itself, and the square root of this squared, which we are calculating, is itself. But if that was a problem, then they wouldn't ask such a silly question. There's a trap here, because what about square root of negative 5 squared? The square root of negative 5 squared is negative 5 times negative 5, which is 25. And if I ask you what is the square root of 25, you wouldn't say negative 5, you'll say it's 5. Because the square root of number is always a positive answer, right? Now here you've got the square root of negative 5 squared is 5. It's not the same as x. So here you have to be a little bit cautious when you're working out the square root of something squared, right? Be careful, don't say it's equal to x. This will be wrong in general. It can be minus x, it can be the negative of this. So depending on what x is, if x is positive, like in this case, right, then it's allowed. But if x is negative, like here, right, then this becomes wrong. Then the answer is not negative 5, but the negative of that, which is 5. Okay, so you have to change the sign. So we have to examine what's under the square root sign. That's very important. And in this case here, if we do this, so we have to examine, is this number positive or negative? Right? Now, here you can see it's positive because you got plus sign and you got 2 positive. This is positive. But this one here, square root of 20 is like 4 point something, and you're subtracting 21 from it. If you subtract 21 from a small number like 4, you're going to have a negative number here. Right? So therefore, this answer here, the square root here is not equal to that, but it's negative of square root of 20 minus 21. Because this number here is a negative number, and you square it, the answer is the negative of that. Right? I hope that is fully understood. Yeah, this is positive. So the quantity that is being squared, oh, I'm supposed to have a bracket here. Sorry. I don't know whether it's like that in the book, but there's a bracket here. I'll have to go and check that. So there it's just itself. Right? And now negative root 20, positive root 20 cancels. Negative 21 and plus 21. And the answer is 42. You got negative root 20 here, plus 21, plus root 20, plus 21. The negatives positive cancel, and this is where you are. Okay, so this was just an illustration of something which you might have thought is obvious, but it is not. It's also interrogating what you mean by the square root of something squared. Okay, so we get on to the next problem. See, now I'm going a little bit fast because I've got 2 problems and I've got 7 minutes to do that. Okay, so so you got 2 empty containers, P and Q, have the same volume. Okay, so originally you had 2 empty containers and they got the same volume. And I'm just going to assume that the shape of the containers are rectangles. Okay, they got the same volume. It doesn't look like it here, but just assume they got the same volume. And sorry, let me do this again. All right, so what happens? I took the first statement and I drew a diagram, right? It's always try to draw a diagram in these problems because it gives you a concrete way of viewing this. Now, water flows. It's called P and Q. So this is a container. One is called P, the other is called Q. The water flows into P at the rate of 4 liters per minute. So I've got this here, P and Q. Water is flowing into this at 4 liters per minute. So you've got water is flowing into this thing now. At the rate of 6 liters. Oh, for Q, it's 6 liters per minute. I've got that also recorded here. Now, after a certain time, we don't know after what time, right? Container P can still take another 60 liters. So you can see this, I've got this in the diagram here. You've got the space for 60 liters here, right? But Q has overflowed by 10 liters. So you got some 10 liters are on the floor here. It's overflowed and it's full. Right. So what causes this? The reason for this is that there's much more water in this one than that, right? So the best way to look at this is that you say, well, what's causing the overflow? Now, I'm going to give you the tricky one first. This one here is being filled at 2 liters per minute more than that. After 1 minute, this has got 2 liters more. After 2 minutes, it's got 4 liters more, right? So we don't know after how many minutes has it got. So how much more has it got? Well, you've got the 10 liters, which is on the floor, plus 60, will give you the extra. Because this thing fills up to the top, you get 60, plus another 10 liters. So the additional amount of water that flowed into this tank is 70 liters. But that additional liters, it was at 2 liters per minute. At 2 liters per minute. And at that additional 2 liters per minute, you've got 70 extra liters. So I'm actually problem solving this thing in words. Because there's a 60 here which is unfilled, the good same volume, and 10 on this side. So this thing has got 70 more, right? Because it's got 6 liters per minute. So therefore, the number of minutes is 70 over 2, which is 35. So in other words, this thing is going on for 35 minutes, right? So the question is, what is the volume of each container? So at 35 minutes, at 4 liters per minute, in 35 minutes, this thing would have filled 35 times 4. So it'll be 140 here, right? Because in 1 minute, 4 liters flow in. After 35 minutes, it would have been 140. So the volume is 140 plus 60, which is 200. You can check this thing out on this side. You can see in 35 minutes, you got 6 liters per minute. So you got 35 times 6, which is 210, right? 35 times 6 is 210. So 10 liters spilled over, so therefore there would have been 200. So the volume is actually 200. Now that is the advanced way of solving it. But if you want to do it in the traditional way and use algebra, we can do it. The way to do that is I'm going to go a little bit beyond time. Sorry about this. Suppose I said, look, I don't know what the time is. We only say after so many minutes. That's unknown. So say the time of filling equals t minutes. Now this is much easier to understand. That's why algebra is very powerful. Now, why is it easier to understand? That's because then I'm going to take out all these things. We don't know these things now. Okay, so what happens here is that, so in 1 minute, if you take the container P, in 1 minute, 4 liters goes inside there. So after t minutes, it'll have to be 4t liters flowed into P, because in 1 minute, liters per minute means in 1 minute, 4 liters flowed. So after t minutes, it'll be 4t. So that is what this water here represents, 4t. Now in this case here, after 1 minute, you have 6t. So you'll have, after 3 minutes, 6t water fell inside there. But 10 minutes overflowed. So therefore, this volume would have been 6t minus 10. See? Because 6t altogether and 10 is outside. So 6t minus 10 would have been inside. All right. So the actual volume, now we have an equation because we know the volume of this is 4t plus 6t. Because now you can add these two. And here you got 6t minus 10. These two volumes are the same. Right? Now you got one equation with one unknown. So the normal thing is 4t minus 6t. You are told to bring all the unknowns to one side. Minus 10 minus 60. You get minus 2t is equal to minus 7t divided by t, and you get t equals 35 minutes, which is exactly what we calculated earlier on without using any symbols. And from this point onwards, you can calculate the volume as we did. It's a little bit easier now because t equals 45. 35 times 4 is 200. 140 plus 60 is 200. And you are right there. Okay, so you've got two methods of solving that problem. And the time is 6:32. So maybe Mark, can I seek your indulgence? Shall we continue and finish this, or shall we push this thing on to the next session? Mark, are you there? Or maybe it's gone. All right, let me tell you how to do this thing, and the next session we will come back. This last problem here is a very interesting problem. I'll just talk about it, and then you can try it out, and we will do it at the next session. You got a square root of some very big number because you got a 12-digit number here, right? And you got a 6-digit number. So when you subtract the 6-digit number from the 12-digit number, you're going to get another 12-digit number, and it's got all kinds of numbers in it. So these are not the same. And you want to work out the square root of it. And you're not allowed to use a calculator. So there's a big problem here. You're not allowed to use a calculator, but you're asked to work out this question. So how do you do it? There's a very nice way of doing it. You use the power of algebra. All right, I'm going to give you just a hint. I will say let x be equal to, you'll see this thing here occurring. Here, this is 2 times this number here, which I've underlined. So I let x be equal to that, and then proceed. Try to work out this thing here in terms of x, and then try to work out the square root. All right. So that is your hint. Next time when we meet, we will discuss that. But let's see how many of you can actually solve this problem using that hint. I'm sure many of you can, but it's a very interesting problem. Okay. Okay, so when we put up the solutions for this, we will, okay, we can put, maybe we'll just delete the solution for the last one. So Mark, you're not there. Don't think you are. And my friend Puma, Lucy, if you when you put the solution out, don't put the solution. Okay, thank you guys. Thank you very much for your attention. Let me quickly find out if there are still 12 participants. And quickly, let me just see if you have any questions, any comments, and we'll be quite prepared to entertain them. Okay, let me just show you my face. Okay, this is me here. Guys, if you have any questions, you can put your hand up. And if the others want to go, you're quite free to go, and I can address these questions.
Prof?
Yes, David.
Yes, there's one question in the chat. They say, what do we do in order to get full mark, 10 out of 10? I think they're referring to the assignment.
Yeah, well, you have to get full marks, you must get a full answer, right? It's a good question, but if you simply write down the answer, you'll get 1 mark, 1 out of 10. The idea is we want you to write down the answer logically, to explain each step, and also it's a test to see how you can write mathematics. It's extremely important. The reason why we torture you in this manner is that in the 3rd round, you're expected to write down the solutions, especially in the senior. So I'm going to give you training now to write down your solutions in detail, right? And explain how you get the answer. So you will get full marks if your explanation is good. But if you simply write down the answer, then that's a chance you take, right? But if your answer is quite reasonable and you have explained some of the things quite nicely, even if your English wasn't too good, and we have an idea that you know what you're talking about, we'll give you full marks. But if there are some things which you don't explain, right? If, for instance, in the last problem you say T is equal to 35 without saying where it comes from, then you're going to lose a lot of marks for that because you're not saying where it comes from. It's your responsibility to explain it. Okay, that's a good question. I've answered that. Are there any other questions?
Can I give into Tugo the platform? Can you explain your question into Tugo? You said what happened if more than one person get total of 90 points?
Oh, don't worry about all those things now. That's at the end of the thing. You worry about the present. Okay, right. This is There's no question of when we come to that situation, then we'll address it. At the moment, it's hypothetical. We don't even know whether anybody will get 90 marks, let alone more than one person. Okay, so don't worry about that. Go and try to answer the assignment problem now. Just worry about what you have at hand. The mathematics, don't worry about the admin. That others will take care of. Any other questions? Yeah, okay, good. To go, David, just answer that. Where do we post your answer?
No,
you have to go to, I think Mark Ancelotti is going to put, he's got all the record of all the names of all the people. He's got one, look at your WhatsApp and you will see the information given in your WhatsApp, because he's got your WhatsApp number, telephone number, as well as your email address. So I think he's posted that in both the WhatsApp and email to tell you how to post the answer. Go and check that. And if you don't know, still don't know what to do, then you have his email address. That's Ancelotti, Ancillotti, I think. And you can just send him an email that says, what do we do? And he will tell you, personally, he'll tell you what to do. Okay? Are there any other questions? Okay, but he has prepared a very nice template where you can just simply write down your answer and all your details. So it's there on the website. I don't think there are any other questions. And if that is the case, thank you very much for attending. Thanks for listening, and have a good evening. I just want to speak to David thereafter. So the rest of you can end the session.